Hello, my name is Justin Overstreet, and today I will be discussing the overall organ system of the nervous system, and specifically focusing on the organ, the spinal cord. Let's jump right in. The nervous system. So, the nervous system is made up of all the nerve cells in our bodies. It's through this system that we communicate with the outside world, and also many mechanisms inside our body are controlled by this. The nervous system takes in information through our senses, processes it, and triggers a reaction, such as making our muscles move or causing us to feel pain. The nervous system is basically the electrical wiring of our bodies. Very important. As you can see in this picture, indicated in red are the different nerves that are involved in both the central nervous system and the peripheral nervous system, two main parts of the nervous system. Central nervous system is safely housed in the brain and vertebral canal of the spine. The peripheral nervous system is the nerves that extend out of the spine at plexus points and extend to the distal parts, such as fingertips or toes, for example. Next, we'll talk about some of the functions, senses, movement, and unconscious functions. There's two things we should consider. Voluntary movements called somatic section of nervous system, and the autonomic nervous system, which controls involuntary movements. An example of somatic would be the simple movement of extending your arm, any motor functions such as this. Autonomic examples include our heart beating, this unconscious action of keeping our hearts beating is controlled by the autonomic nervous system. Next, we'll talk about the spine. This is very important because it encases the spinal cord. It's made up of 33 bones called vertebrae, and there's flexibility involved by discs and fibrous ligaments that allow this. It provides stability and protection for the spinal cord. These are two important things that the spine does for us. The spinal canal also houses the beginning of the spinal nerve roots. These nerves leave the spine, exiting the spinal canal through foramina to branch out to the body. The spinal cord and nerve roots are suspended in a liquid called the cerebrospinal fluid. Membranes called the meninges act somewhat like a casing on a sausage, wrapping up the spinal cord, nerve roots, and CSF inside the spinal canal. Moving on, we have some images here that will help us better understand the human spine and the spinal cord. The spinal cord extends from the foramen magnum, where it is continuous with the medulla, to the level of the first or second lumbar vertebrae. As you can see here, the human spine is made up of cervical, thoracic, lumbar, and sacrum. These parts. These are the important parts we'll talk about involving the spinal cord. The cord is sheathed in the same three meninges as is the brain: the pia, arachnoid, and dura. The dura is the tough outer sheath. The arachnoid lies beneath it, and the pia closely adheres to the surface of the cord. The spinal cord is attached to the dura by a series of lateral dendriculate ligaments emanating from the pial folds. All spinal nerves except the first exit below their corresponding vertebrae. In the cervical segments, there are 7 cervical vertebrae and 8 cervical nerves. C1 through C7 nerves exit above the vertebrae, whereas the C8 nerve exits below the C7 vertebrae. It leaves between the C7 vertebrae and the first thoracic vertebrae. Each spinal nerve, here's a spinal nerve in the picture here, the blue, is composed of nerve fibers that are related to the regions of the muscles and skin that develop from one body segment. The spinal segment is defined by dorsal roots entering and ventral roots exiting the cord. As we can see here in the transverse section of an adult spinal cord, we have white matter and gray matter in the inside. In the very center, there's a tiny central canal filled with CSF at the center. This is important. Let's look a little more in depth of the spinal cord. Here we have sensory roots, the spinal nerve, and a little more in depth. And these arrows indicate the electrical flow. The arrows pointing down are the impulses from the brain as a response to the impulses that were sent to the brain, such as something getting hot and the reflex of pulling your hand away as to not get burned. An anatomical description of the spinal cord can be described as a delicate tube of nerve cells and fibers extending from the brain to the lower back, composed of white and gray matter. Fun fact, the spinal cord is about 40 to 50 centimeters long and 1 to 1.5 centimeters wide. The spinal cord functions to transmit nerve impulses and for reflexes. All movements and sensations are relayed from the distal parts of the body through the spinal cord to the brain. In addition, the autonomic nervous system is serviced by the spinal cord by transmitting information to the brain from different organs involved, such as the heart that we discussed earlier. The spinal cord plays a role in the very important balance of our bodies called homeostasis. First of all, the spinal cord serves as a conduit for signals between the brain and the rest of the body. So simple musculoskeletal reflexes are attributed to the spinal cord, and it as a good conductor. In addition, just the simple act of balance, our bodies respond to sensory organs in our feet and legs that communicate and tell us where we are, corresponding to how we're standing on the level of the ground. So many ways homeostasis and the nervous system are tied together. Next, we'll read complex interactions govern the interplay of the central nervous system and immune systems. These two systems interact together, and spinal cord injury impacts homeostatic maintenance, including the generation and activation of B cells. So our bodies seriously need the spinal cord. Next, we'll discuss some of the diseases and injuries that are common to the spinal cord. Some signs and symptoms of spinal cord injury include loss in movement below the point of injury. So neck and back pain are also indicators of this. Pain is a symptom because healthcare providers can't necessarily see this. Next, we'll watch this short video,
which provides further protection. The spinal cord is a delicate tube of nerve fibers and nerve cells that extend from the brain to the lower back. Together, the brain and spinal cord make up the central nervous system. The function of the spinal cord is to relay messages from the brain to the body and from the body back to the brain.
This video describes the electrical impulses sent from the brain to the body, and showing this, I just wanted to demonstrate how it's almost like a flow of impulse, and much like the flow of water goes through a water hose, a kink in the water hose stops all the flow from the other end, much like the spinal cord. If there's an injury around the neck, everything below it will lose the function that the spinal cord provides. Next, there's some common spinal cord diseases we'll look at here. The image provides a picture of degeneration that comes through time. And some erosion of the spine and the nerves, spinal nerves right there, indicates some pressure and discomfort that is diagnosed as arthritis that many people experience later in life. Other things we'll talk about today include myelopathy. This is a reduction in the spinal cord's ability to send signals between the brain and body, and it causes weakness, numbness, and bowel incontinence. This can be caused by compression of the spinal cord. Next, we'll skip down here to radiculopathy. This is a reduction in the nerve's root's ability to send signals between spinal cord and the body. This can cause pain, weakness, or numbness. The arms and the backs of the legs are common to feel this sensation when this is an issue. It can be caused by the compression of a root nerve. Stenosis is a narrowing of the spinal cord, and it can compress the spinal cord and lead to myelopathy. This is serious, and anytime there's compression to the spinal cord, there's usually need for intervention because this is serious, and we will discuss that in the following slides. Lastly, arthritis, which is demonstrated in the picture here, is joint inflammation that causes pain and stiffness. This can occur when the cartilage in the joints wears down. Right there. In addition, a dermatome is an area of skin supplied by peripheral nerves, originating from a single dorsal root ganglion. If a nerve is cut, one loses sensation from that dermatome. Dermatomes can be precisely mapped on the body surface, and loss of sensation in a dermatome can indicate the exact level of spinal cord damage in clinical assessment of this kind of injury. So this is an interesting thing to note when talking about injuries to the skin. Next, we'll look at an example of a spinal cord contusion. Briefly before we watch this is Ryan Shazier of the Pittsburgh Steelers. Goes in for a tackle, and you'll see a contusion. Let's take a look at it.
Break on the ball. Went in there with his head down, and that's never a good thing.
As you can see, there was swelling around this area that was impacted by the tackle, and this concussed the spinal cord in a way. And he's still recovering, but it takes time, and he's walking. It just shows the seriousness and impact that it takes to injure the spinal cord. Next, we'll discuss treatment. There's non-surgical and surgical treatments, and depending on the severity of the situation and kind of injury, one of these two options can happen. So non-surgical involves physical therapy, treatment with hot and cold compresses. This helps with swelling. Also, there's medicine. Usually for non-surgical treatments, this is the effective treatment when there's no spinal cord or nerve root compression. Many degenerative conditions fall under this treatment plan, such as arthritis, for instance. Next, surgical intervention is required for situations that require decompression. This includes myelopathy and radiculopathy. So there's the treatments. This concludes my presentation of the spinal cord. I hope you enjoyed it. Thank you.